Let's explore the normal distribution, often called the bell curve. We will focus on understanding the 68, 95, 99.7 rule, which helps explain natural variations in data. The normal distribution is a symmetrical, bell-shaped distribution. It is perfectly balanced around the mean with a single peak at the center. This distribution is foundational in statistics for modeling random variables. The 68, 95, 99.7 rule is also known as the empirical rule. Approximately 68% of the data falls within one standard deviation of the mean. About 95% of the data falls within two standard deviations. And 99.7% of the data falls within three standard deviations of the mean. Here is a visual representation of the bell curve, showing standard deviations. The area shaded in red represents 68% of the data, falling within plus or minus one standard deviation from the mean. The area in orange shows 95% of the data, within plus or minus two standard deviations. And finally, the green area represents 99.7% of the data, within plus or minus three standard deviations from the mean, labeled as mu in the diagram. Consider a real-world example: math test results. If the mean score is 75 and the standard deviation is 10, then 68% of students score between 65 and 85. 95% score between 55 and 95, and 99.7% score between 45 and 105. Another real-world example is human heights. For adult men, the average height is 5 feet 9 inches, or 175 centimeters, with a standard deviation of 3 inches, or 7.6 centimeters. For adult women, the average height is 5 feet 4 inches, or 163 centimeters, with a standard deviation of 2.5 inches, or 6.4 centimeters. Now let's look at a Python example for generating normal data. We import the NumberPy library and seed the random number generator for reproducibility. We then use the numberplot_random.normal function to generate 1,000 data points with a mean of 100 and a standard deviation of 15. Finally, we print the mean and standard deviation of the generated data, along with ranges covering 68% and 95% of the data. The generated data will have an approximate mean of 99.7 and a standard deviation of 14.8, with the majority of the data ranging from 85 to 115. Here are the key takeaways from our discussion on the normal distribution. Remember the 68, 95, 99.7 rule. 68% of the data falls within one standard deviation, 95% within two standard deviations, and 99.7% within three standard deviations. Also, recognize that the normal distribution is found everywhere in nature, from heights and test scores to various measurements and natural phenomena, all following this bell-shaped pattern. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.